Hi, in this video we're going to apply L'Hopital's rule to find the limit of a function when the indeterminate case is 0 over 0. So if we are trying to find the limit of a function as x goes to a, f of x over g of x, if it's the indeterminate form where we end up with 0 over 0, up until now we've kind of been stuck. But what L'Hopital's rule says is that we can take the derivative of the numerator and the derivative of the denominator, and in that limit will be equal to the limit of f of x over g of x. And again, the main assumption is that the limit to the right does exist. So I have a few examples of how to do this. All right, here's our first function. Notice that if we plug in 0 in the numerator, 0 in the denominator, we'll get 0 over 0. So it's the indeterminate form 0 over 0. But now if we take the derivative of the numerator and the denominator, applying L'Hopital's rule, we would get 5 cosine of 5t, that's the derivative of sine 5t, over 2. Okay, and now when we plug in 0, the cosine of 0 is 1, times 5 is 5, and with the 2 in the denominator, so we know that this would go to 5 over 2. So that would be my limit as t goes to 0 of this function. Let's try another one. Again, in this one, if I plug 0 in the denominator or 0 into the numerator, I get 0 over 0, so that's the indeterminate form. But again, we can apply L'Hopital's rule, and we would get, well, the derivative of sine is cosine. Derivative of minus x is minus 1, all over 3x squared. Okay, but now notice that again, I would end up with 1 minus 1, which is 0, over 0. So I still am in the indeterminate form. The cool thing about this rule is that it can be applied again. So all I'm going to do is differentiate the numerator and denominator again. Now I'm going to end up with minus sine of x. The derivative of cosine of x is minus sine of x. The derivative of negative 1 would be 0 over 6x. Again, I got 0 over 0, so hopefully the fourth times, or the third time's the charm. Now I get the derivative of this would be minus cosine of x over 6, and now when I plug in the 0, I get the cosine of 0 is 1, minus 1 over 6. So this would approach minus 1 over 6. I have one final example, okay, and that is this one. Again, x squared, if I plug in 0, I get 0. If I plug in 0 here, I get 1, but the natural log of 0 is 0. So again, I'm back at 0, 0, which is the indeterminate form. So what I can do is once again take the derivative of the numerator and the denominator. That would give me 2x over, okay, all right, the derivative of the natural log of secant of x. Well, the derivative of natural log of x is just 1 over x, so that would give me 1 over secant x times the derivative of this part. Well, the derivative of secant x is secant x times tangent x. And now notice here, these would cancel. So this is going to become the limit as x goes to 0. 2x over tangent x. Okay, again, if I plug in 0, I get 0 over 0, so we're going to apply the rule again. Okay, I get a 2 in the numerator. The derivative of tangent of x is secant squared x. But now, if I plug in a 0, here I get a 2, here I get 1 squared, or 2. So the limit would be, as x goes to 0 of this, would be 2. I hope these examples help. If you need more help, please just let me know.